Hi, this video is a walkthrough and a substitute for the Lab 10 Lunar Lander simulation lab. So hopefully you've already seen the first part with the introduction video, talking a little bit about the difficulties the original Apollo missions had landing on the moon. They actually built a simulator to kind of project how much fuel they would need to land on the surface. And actually, the previous mission before Apollo 11, Apollo 10, they went to the moon, went down to a certain height, and then tested going back up. So they didn't land fully to the surface in that mission, but that all the tests worked fine for that mission. So the go ahead was given for the following mission with Neil Armstrong and Buzz Aldrin. So it's a relatively short lab, but it's to give you a sense of how to, or the difficulties in a landing on the surface of the moon, which does not have an atmosphere. So you can't use any type of, like, say, parachute, such as you can with on the Earth or even on Mars with its thin atmosphere. And it's solely based on you control your thrusters to control your velocity, that you can reach the ground at a slow enough speed not to crash. So that was that combination, looking at basically your velocity and monitoring how much fuel you have. That was the main difficulties with this mission. So there have been numerous lunar landing simulations produced. The one I had originally had you to use was the one done by University of Colorado at Boulder, the physics department. They have their PHET simulation program, but unfortunately they used Adobe Flash for it. And as of early this January, many modern browsers no longer can use that because Adobe is no longer providing support for that software. So unless you have like an old computer here that I'm using as a spare that hasn't been updated to the most version Adobe, or updated browser for a while, you won't be able to run this particular software. So I'm recording this video so you can complete the lab. Now I do have a couple alternates, but they don't really match the full instructions for this. But let's take a look at the simulation. Okay, so here you have kind of display of the lunar background, and it gives you this kind of introduction. So for this simulation, you are allowed to use a main thrust that comes from the bottom of the lander, and tilting thrusts that allow you to move left and right. So with this, kind of the idea is to try to see this connection between acceleration and velocity, and then also trying to get down to a soft speed, less than 2 meters per second when you touch the ground, while keeping an eye on your fuel. And it's very easy to kind of run out of fuel if you are using too much of kind of thrust. So let's see. We're going to start off here and try to land. And yeah, as we go along, you can look at some of these questions. So what happens if you use the lander too much thrust? What happens if you use too little? So we're going to try landing safely first. And this simulation does allow me to kind of incrementally increase the thrust and reduce it by hitting up or down, or I can toggle the full thrust. So let's start. And I'm going to put the vectors there so you can actually see the lines corresponding to my current velocity and my current acceleration. So here, as I'm descending down, now as I'm kind of free falling here, just see here, if I do too much thrust, I go back up. And there you go, soft landing. So that one I was able to land it at 1.7 meters per second, soft enough that it wouldn't damage the structure there. Now, of course, when if you've done the reading for this past module talking about the Apollo missions, they of course limitations, technology, and time. They did design the module such to be its own mini rocket. So when it took off back again, back to meet up with the orbital main rocket that was left in orbit with one of the other astronauts, most of this bottom superstructure would be left behind. Also, anything they brought that they could leave behind, such as the later missions, they brought a lunar buggy that was left behind, and that way they could replace that with, say, lunar samples. So you can see here, you have enough information to answer those first two questions there. Kind of, I used too much thrust, it was going up and away. If I used too little thrust, I began falling, descending. So here, the part of the game is it also allows me to kind of move on, see if I can get some more points if I go left or right. So question 2, describe the sequence of maneuvers you need to execute to get the lander to move sideways, and then carry a soft landing that's nice and vertical. And then 3, you can probably also see that is what color the thrust vector and what color is the velocity. How can you tell? All right, so I have plenty of fuel left, so I'm going to launch off. Click on my screen. So here I'm up in the air, or above the moon's surface. Now, since I only have a main thrust there, I got to tilt my thing such that part of my acceleration is horizontal. And that's probably a little too much. So I got to cancel that out. And then I'm going to slow myself down before I disappear. All right, so I do have some still velocity there. So what I'm looking at is for the velocity left X and Y there. Let me get back up here before I crash. Now I want to try to get that as close to 0 so I'm not sliding when I hit the ground. Now, see, did a little too fast. But as you can see here, crash landed, did above 5. And that kind of ends it for me and gives me a score of 15. There we go. Let's try this again. Let's reload. So right here, I'm just showing the full thrust. So it can be helpful if you're going too far, falling too fast, but of course, it's much more harder to regulate that as opposed to just softly. Okay, so hopefully that shows a little of the controls. So again, here's another soft landing. Okay. So as I went along, do you think it was better for me going from maximum to zero most of the time, or uh, building up on thrusters? And the points that I got so far was 15 that you can put in the bottom there. So that's pretty much this simulation here. Again, it's more of a bit of a game. And it's unfortunate you're not able to run it on many of the computers anymore. But I do have another two options that you can play around with. One is let's see, an arcade version that came out, I believe, 79 here. And it is a little more difficult because instead of just falling down toward the moon, you do have some horizontal velocity that you need to compensate for. It's very similar in design, where you have to tilt to get any part of your thrust to counteract your horizontal motion, and the ground is a bit more rugged. So let's click arrows to play. Doesn't have quite the amount of sound. Well, it does have a little sound there. This one is not as forgiving in terms of fuel. There you go. I landed there. So this one allows you to go on, and if you have more fuel left, you can go and get more points. So more difficult, rugged terrain, of course, gives you more points. And this does match what occurred with the Apollo missions. The first two or three landed in the Mare, and then they shot for more difficult terrain, which you do find in the Lunar Highlands. And that terrain was a little too difficult, so I blew up there. So that is one option that will allow you can actually do yourself. And this is actually run by, I believe, a museum in Ireland that did a art project where your motion match actually drawing out your velocities. It was kind of cool. All right, let's see. Another one I did find, which is kind of like um, the one we tended to use. The only difference is it's from the point of view of being inside the module. So you get to control the velocity, the throttle. I'm sorry, the throttle, but you don't have an outside view. So unfortunately, I can't use this one to show kind of the vectors, because it doesn't show it. And it's also, I'm probably the oldest side of the group here. So here I am descending my altitude there. But the goal is the same way. Is you want to reach a velocity. This is in feet per second, which a soft landing would have been 2 meters in the other. So, and this one isn't not as forgiving with fuel, so I'm going to cut my fuel usage for right now until I fall to a certain thing. Try that. And that might not be enough there. I'm gonna crash. So in this case, I'm going to leave my throttle on 50. So my right now at this point, my velocity is the same. So I'm still falling down, but I am not accelerating. On the other hand, it is using quite a bit of my fuel to do this, though. So astronauts would before they did land the Apollo, they would do the simulation to make sure that they can get the right altitude and fuel usage to safely land without basically using up all their fuel. And really the same type of measurements and ideas are put into kind of the current SpaceX rockets, where they're able to kind of land the main booster, basically they're able to land back down to the ground. And I want to lower my velocity enough. We're low on fuel here. And in his case, I was successful. Okay, so you can try this one as well. Again, it's inside the cockpit, so you can't see the overall terrain, but it provides the same kind of experience there. Okay, that should be enough for this. So I'll stop it here. And those who have, again, any issues with the labs, please let me know. We'll try to get more recorded videos out to you.